Hey guys! Today we're going to be learning about systems of equations, specifically how to solve them through graphing. Let's get started! So to get started, let's first talk about what a system of equation is. So this is basically what a system of equation looks like. It's really just two equations. So the point of systems of equations is to see what coordinate point or what point on the graph satisfies both equations. So basically, if I plug in a number into both equations and it outputs as true, then we know that that is a solution to this system of equation. So for systems of equations, the solution will always be a coordinate point. So for this specific one, the solution is 51, 30. So we'll talk about how I know this in my next video, but basically, if I plug in 51 into 3x plus 2y is equal to 192, it should output as a true equation. And if I plug it into 2x plus 3y is equal to 213, that should also output as true. So if I plug in the same coordinate point into both equations and both equations output as true, that means that those two are a systems of equations and that coordinate point is a solution. So now let's take a look at graphing these systems of equations and how we're going to solve it if you see two lines that are on a graph. So we have our two equations here that are a systems of equation, and we want to solve this by graphing. So the first thing we're going to want to do is get both equations into slope-intercept form so we can graph them both. So as you can see, this first part has already been done to us as the equation in blue, y is equal to negative x plus 5, is already in slope-intercept form. But the first one isn't, so let's put this into slope-intercept form. So we're going to subtract x from both sides, and we're going to get minus 2y is equal to minus x plus 8, and then we're going to divide both sides by negative 2, and we're going to get y is equal to half x minus 4. So our first equation in slope-intercept form is going to be y is equal to half x minus 4. So these two are the ones that we are going to want to graph on our graph. So let's do that first. So let's graph the first one, y is equal to minus x plus 5. So our y-intercept is going to be 5, so let's count up to 5. 1, 2, 3, 4, 5. So that's going to be our y-intercept. And now we're going, the slope is negative 1, so we go down 1 and to the right 1. That's going to be right there. Down 1 and to the right 1, and that's going to be right there. And we keep going until we have enough points to connect with a line. So let's connect these points with the line. And so this is our graphed line. Now for the second one, we're going to have y is equal to half x minus 4. So y-intercept is minus 4, so let's go down 4. And the slope is 1/2, so we're going to rise 1 and go over 2. Rise 1 and go over 2. Rise 1 and go over 2. And we're going to connect these points with a line to get our graph. So now that we've graphed both of these, our solution to the equation is going to be where both of the graphs intersect. So as you can see, this graph only has one intersection point, which is right here. So this point right here is going to be our solution to this equation. So this point is 1, 2, 3, 4, 5, 6. It is 6, comma, and then it's -1. So our solution to this right here is 6, comma, -1. And so we solved this with graphing. And if you just want to be sure, we can also check this. So to check this, we plug in 6 for both of the x's and -1 for both of the y's. So let's start with the first one. So we have y is equal to, and we sub in -1 for y, and that's going to be equal to -x, and we sub in 6 for the x, and then plus 5. So -1 should be equal to -6 plus 5, and -6 plus 5 is equal to -1. And so that means that this is true. Now for the next one, we have y, which is -1, is going to be equal to 1/2 times x, which we're going to sub in for 6, minus 4. So -1 should be equal to half times 6, which is 3, minus 4. And so -1 should be equal to 3 minus 4, which is -1. And since -1 is equal to -1, that means that this is also true. So since we plugged in the same coordinate point into both equations and we got a true output for both, that means that we have confirmed that -6, -1 is the solution for this one. So let's solve one more. So over here, our first one says y is equal to 7/3x plus 5, which is already in slope-intercept form. So there's nothing to do there. Our second one says x is equal to -3. Now you may notice that this does not have a y variable in it, but that is completely okay. Although it does not have a y variable and it's not in slope-intercept form, we can still graph this on the graph, and I will show you how. First, however, let's graph our first equation. So our first one says y is equal to 7/3x plus 5. So that tells us that our y-intercept is 5. So let's put a dot there, 2, 3, 4, 5. So here's the y-intercept. Now the slope is 7/3, so we could rise 7 and then go to the right 3 to find our next point, but that's going to take us off of the graph. So instead what we're going to do, we're going to go down 7 and to the left 3. So let's go 1, 2, 3, 4, 5, 6, 7, and then to the left 3. So 1, 2, 3. So around right there. And so all we really need is 2 points. More than 2 is not necessary, but you can do it for a more accurate graph. But since we don't have enough space to do another one, we're just going to stick with 2 points instead of more. So let's draw a line here. And so this is going to be our line for the first one. Now for our second one, it just says x is equal to 3. The way that we are going to graph this is we're going to go where x is equal to -3. So on the x-axis, we're going to go to -3. So that's right here. And really, it's so straightforward, it's so simple. So all you have to do is draw a completely vertical line from that -3 point on the x-axis. And so that's right there. And so this thing is going to be our line for this one. So if it says x is equal to -3, all you're gonna have to do is draw a vertical line at where the x-intercept would be -3. So now all we have to do is see where these two intersect. So I know my graph isn't perfect, but it intersects somewhere around here. So by looking at this, we can see that the x value is -3, and the y value is like -2. So that should satisfy both of the equations. Now, if we want to double check, all we do again is just plug the rest in. So to check, we can do So to check, we can plug in -2 for y, which is going to be equal to 7/3 times x, which is going to be -3. And then we're going to add 5. So -2 should be equal to 7/3 times -3, which is going to leave us with -7 plus 5. And -2 should be equal to -7 plus 5, which is -2. So since -2 is equal to -2, we know that this is correct. So for our second one, we plug in -3 for x, which is going to be equal to -3. So it's telling us that -3 should be equal to -3. And that is equal to each other, so we know that this one is also correct. So plugging in the same coordinate point into both equations gives us both a true value, which means that this is our final correct answer as the solution to this system of inequalities. So that's it for today, guys. If you want more videos like this, please like and subscribe. Thank you so much for watching. See you next time. Bye!